So in this video, we talk about gambling, and I had already given a lot of context, and I think this is one of the first things I looked into back in Mumbai, and system was a bit different, but it was always good to crunch the numbers. So anyway, I will first explain my notation, and this I had read from some book. I don't recall the name, but I mean, it's pretty simple. It's pretty standard. You can use it yourself. So, first thing, let's say there are n horses, and just to make it simple, I will maybe assume initially that there are two horses only in the race. So, n will be 2, and W is the symbol of wager, total amount of bet I put on that horse, right? I mean, if there are 10 horses, I can put maybe 9 of them at 0 and 1 of them at 100. So it depends. I mean, but just for simplicity, I'm considering these are the wagers. Now, this is not the wager I put, but this is on the whole race, this W. And if the horse J wins, the bookie will pay out this much. So BJ is the bookie odds. So to simplify the system, I mean, how the bookie sets the odd, let's say my B is some like 1 comma 2. Then if the first entry is 1, means that if you put $1, you get $1 on top. If you put $1 on the second horse, you get $3. So that's how, I mean, this plays out. So basically, sorry, not $3, it's depending on that if you put 1, because I'm scaling it by 1. So, okay, just to make it clear, if this first horse I make the bookie odds as 1, and if I put $100, then I will win 100 into 1 plus 1, which is 200. And if I put, let's say, maybe the odds are 2, then I win 300. So that's how the system of bookie odds is, and I'm not sure, maybe this is pretty much the standard. So that's why this notation BJ, depending on if horse J wins, then bookie pays out this much. So what is bookie's job? I mean, I will always want to be a bookie in this scenario. I mean, it's pretty simple. All he has to do is somehow make sure that in any scenario, whichever horse wins, doesn't care what are the probabilities, it has to be always less than the total wagers put, right? If any time you find that the horse, if this wins, the total wager won't be able to cover it up, bookie is at a loss. And I can simplify this expression just by simply by moving things around by saying that bookie has to set the odds such that the total sum of wagers divided by WJ, which is my wager on horse J, minus 1. So this has to be true for all horses, right? And this will help us find the arbitrage. Most likely you won't find it because, I mean, in these races it won't exist, but just for understanding the system, it is good to kind of visualize it. So hopefully this makes sense. Then what are the odds set by the bookie? For example, I choose this other odds set by the bookie. Let's say this, B is this. I assume some random number, or I can, for making it simple, I can maybe, since I know the total number of horses is 2, I can just make sure it's 1 comma 2, let's say. And the total wagers that I put are, let's say, 100 comma 200. Now what happens? These are the wagers placed. Total wager is 300. What will happen? If the horse 1 wins, bookie makes $100. Horse 2 wins, bookie makes minus 300. That means he loses. So how can you fix this? What if I change this to 1.5? Still, I don't make money. What if I change this, or if I change this to 0.4? Now, in both cases, I make money. But what if the amount changes? What if somebody bets big on this? So, in two horses, as you will see, it's a kind of a problem to solve, but it becomes very easy to manipulate because then I can easily change my amounts. When the number grows larger, it is not so easy to have this kind of arbitrage, have this kind of opportunities. I mean, because this becomes like a heads and tail case, right? I can simply do this, right? But again, changing the amounts, this becomes a problem. How do I calculate this? I've done very simple calculation. This sum of wagers, bookie odds, and total wager is this. Total wagers is sum of W. Bookie makes total wagers minus 1 plus PI because he has to pay out this much times the wager amount, right? So very simple calculation. Horse 1 wins, bookie makes this. What if their horses are 10? Then I need a better notation. So, I mean, I cannot directly think of the numbers. So maybe this plus 1, maybe something like this. It will be easy. Okay, it is not allowing me. Sorry. Okay, so these are the bookies odds, and maybe I will keep the digits to 2 just to make it slightly more attractive. And okay, I have to similarly increase the wagers as well. So maybe for wagers, I will do this times 100 or maybe 1000, easier. Okay, these are the wagers. This is this. Total wager is 5,977. Always makes money. So here, as the number of horses grow larger, I can easily control this by even by having this, I will still have this, right? Unless there's something like wager placed on one horse which makes me lose money, I will always make money. Now, this is about the bookie. How about you when you gamble? If you can find such a combination where this is greater than 0, then this is an arbitrage. Because if for all j, this is true, if you can somehow make your wagers, now W is here denoting your wagers, the wagers that you have done. If somehow I can figure out this, I can have an arbitrage. So this means I have arbitrage. So let's say my wagers are always 1, 1, 1, 1, 1, 1, and then I just do the calculation. This is my money made if this horse wins, because I have placed wagers on all the horses based on the bookie odds, and this was my condition. This WJ greater than this divided by this. So in this case, I will always lose money. And my mean wins is this, standard deviation is this. How can I change it? For example, if this is true, but then all these are false, right? All of them should be true. But here you make money. Here you make money when first horse wins, but nowhere else. So let's say I remove this condition, this condition, this condition, and check. So first horse wins, you make money. First horse win, you make money. Rest of them, you lose. Mean wins is this, deviation is this. Can I change it? Maybe. Overall objective might be to do two things. Maybe you want to minimize the deviation, or maybe you want to maximize the mean. Cannot have both. So that's why when I say gamblers have the intuition of looking at the data in a large variety, this is what they are trying to do. If you are a calculated gambler, you will try to do this kind of calculation. And this is just for arbitrage, but this never works. I mean, most likely there won't be any arbitrage. So what do? You calculate probabilities. And you'll see I just started with some probabilities and then just normalized it. And these are my probabilities of the horse that can win. Maybe based on bookies odds, maybe based on my calculation. And then I check the expected PNL. How much will be made if these were the probabilities? So I can minimize the expected PNL, or sorry, maximize the expected PNL just to make sure it works out. So maybe if I change this, let's say to 44, and then see the expected PNL, okay, it is going down. So it is not helping because my probability is this. What if I increase this number? Then expected PNL is still going down. So somehow, I mean, it's simple to play around with the numbers, but to get the intuition of why the numbers work, what is the mathematics behind it, it's it's better to dig down into visual interpretation, which I will discuss in the next video, of how the graphing works, because you can easily think in two dimensions. And from two dimensions to three dimensions to four dimensions, it is very simple to kind of visualize the scenario. I hope this helps, and I will put out this notebook just for people who are interested in playing out.